My name is Sam, and I work for Huawei Technologies. So today I'm going to talk about data center interconnect solution. So I'm not going to belabor on a specific solution, but I'm going to talk about some of the things which have evolved to provide different kinds of solutions. And so before that, I'm going to talk about some of the requirements and what actually means with respect to data center interconnect. Then I'm going to talk about some of the solutions. Then I'm going to talk about some of the future things, what needs to be done in order to provide a future-proof solution, accounting with all the virtualization and with all the new SDN technologies coming into picture. So the agenda is, first I'm going to talk about the requirements and the motivation, then followed by different solutions and SDN in future. So as most of you know, wow, interesting. So I don't know how to explain. Okay, so the evolution of internet, right? Primarily, I don't know if any of you actually were involved in some of these technologies when they were started, when they have started. So the reason why I have put that slide is till about late 90s, the evolution was more towards how to provide different services and different control plane protocols. And after 2000, the paradigm has shifted towards cloud services. So what exactly cloud, right? So when you talk about cloud, you pretty much think everything in the internet, and all I need to do is access the service from the internet, or some service provider is going to provide in different form where you can actually access over the internet. So the hosting of the service you really need not have. So for example, you take enterprise, you want to have some backend services like email, office. So it's not necessary that you need to actually install, for example, all the backend work in your premises. Rather, you would like to outsource whole of your service model to the service provider like Amazon. So you can have the whole backend service provided over the cloud. Similarly, Salesforce, you can provide all kinds of sales specific details over the cloud. Similarly, you have different type of applications. If you have used some of the Google services, they are actually provided over the cloud as well. And off late, you can actually even avail some of the infrastructure services. If you want, for example, a high-end computing service, you need not buy a high-end computing service server. Rather, you actually ask for that service and you virtually connect to that infrastructure. So fundamentally, there are three components in any of this cloud service. First one is storage, that is how to store the data, followed by computing. You need some horsepower to compute the data. Then the connectivity, that is the network. So it boils down to three fundamental components: computing, storage, and network. So you take any of these enterprise or service provider or application provider, these fundamental components forms the framework for cloud service. So at least this is right. Okay. So if you read this, later on I'll share the presentation as well. So it's a hilarious thing. What exactly a cloud service? Take a minute to read, and if you understand, that's good. So what it's saying is that everything will be on the internet. So that is what is the cloud service. So people believe you make fools of the customers, saying that everything on the cloud, on the internet is cloud service. So just a hilarious thing. So these are the attributes in computing. For example, you want to lease out some computing resources or offload some of the computing needs. or you want to allocate on demand. For example, you are providing a third-party service and you want to avail some of the computing services so that you can provide to your customers. So you can actually get some of those services or provide those services on demand as well. And similarly for storage space and hosting, like a lot of web services are hosted on the internet. And similarly, the data protection, right? You need not really worry about how much of my data is redundant. So that is like because the provider actually makes sure that the data is protected, and so he'll have replicating services across different data centers. Similarly, network services. So you can provide different kinds of network services to the customer. So who are the stakeholders? So I'm going to give few examples who the stakeholders are. Let's take application service providers, so like Google and Amazon. Then those kind of providers provide public service, like email, documents. They can provide all kinds of services. Then infrastructure, right? You want to get the 8-core Linux server, right? And you can go and ask, the service provider and say, hey, I just want the 8-core, 4 gig or 16 gig RAM, and blah, blah, blah. You can specify those things and you can get that infrastructure. And similarly, universities and research centers, they have a lot of need to have different services and different kinds of applications to be provided. So the other aspect is service providers, like Deutsche Telekom in Europe or Orange, French Telecom. And so there are many other service providers who actually provide not only network services, they also provide different kinds of application services along with hosting and storage. And if you talk about enterprise, for example, you take your own company, they want to have different services. So they can build their own service model and provide as a cloud service. So these are different kinds of stakeholders. So what are the challenges? The main challenges are how exactly you can provide a seamless delivery of this service. So when I say seamless, it is end-to-end. So it's not like you provide bits and pieces and let customer figure out those services. Rather, you want to provide a seamless service. Then you want to provide the security of the data. So it shouldn't actually cause any disruption or corruption of the data. So you want to have proper response time, and the data should be secure. It shouldn't go into different hands so that it's get compromised. Then mobility. These days, everyone carries iPhone, iPad, and the different kinds of Android devices. So the services are mobile. Today you could be in Poland. Tomorrow you could be in Paris, or next day you could be in Los Angeles. So you need to have the similar kind of service wherever you go. So I shouldn't, as a service provider, I shouldn't be restricted, or I shouldn't restrict my customers so that it is constrained only to a specific geographic location. So I need to have that kind of service available as well. Then traffic modeling. For example, if I'm in Poland, I would rather have my caching services located in Poland, and rather than going all the way from routed through different country and coming back to Poland. So traffic modeling is very important. Then integration, right? It's not only like you have the service, but you need to manage, you need to orchestrate. So, and the content should be available wherever you are. So those are fundamental challenges in providing cloud services. So the reason why I gave a basis for cloud services is because that is the paradigm where the whole service model has shifted. So it is not like you have a specific geographic location and you provide services from there. Rather, it should be global. So in order to do that, you need to build a good data center model. And in order to have good data center model, you need to have good interconnectivity as well. So what are the interconnection issues or different kinds of requirements in interconnection? So let's take some enterprise data centers. The first and fundamental thing is security, right? You could have campuses, for example, let's take a university as an enterprise. The university might have a campus in one location and another campus in another location. So there are different students accessing to different services, and each student should be able to access different service, but not all of them. So that means the security of the service should be maintained, irrespective of where the student is accessing from, which campus he is accessing from. So the security should be the primary concern. Then scalability, because number of users will be dynamic, gonna be dynamic, so you need to have a lot of scalability issues you need to resolve. And of course, redundancy and high availability. For example, you want to access some of your paperwork in the university. You want to make sure that it is available all the time. You don't want to take out that service. Similarly, mobility and the failure and detection of any of the issues, right? So the primary goal for enterprise data center is to reduce CapEx and OpEx. CapEx means like how much you're going to invest to provide a service in terms of physical resources. And operationally, you need to be pretty simple. So that means you should be able to orchestrate, you need to be able to manage, detect, and identify any of the faults, so on and so forth. Then interconnection of SP data centers, it's not only the above requirements. The other thing is you have different tenants. Because as a service provider, I cater to the needs of different clients. So I have much more requirement built into my needs as a service provider. So service provider data centers should also cater to small enterprises as well as provide network in such a way that they need to meet SLAs and all those requirements. So some other fundamental requirements are mobility and DC migration. Because when you want to move, these days everything is a virtual machine. For example, you could install on your PC multiple operating systems, right? It's as simple as that. So when you have VMs, for example, you avail a data center resource. Let's take computing resource. I take a Linux server with certain requirements, and next day I want to move from a specific data center to another data center. You need to make sure that all the properties are carried over from one data center to another data center. So that means you do not want to shut down that Linux server, that is the VM, and re-enable on the other data center. I would rather have the same thing moved without bringing down that server. So that is the very, very difficult thing to do, because it also involves the storage, the memory, and all of the networking aspects as well. The other issue where you see is the man-made disasters. It could be like bringing down the network by configuring it wrong. So that doesn't mean that your network has to go down completely. Rather, you need to have a failover and the redundancy built in. Then there are natural disasters as well, like an earthquake or something could bring down the data center. But if your for example, your police service and those kind of things are provided, if an earthquake happens, if the data center goes, then if the services also goes down, then you cannot really make use of those services. So you would rather have those services available as well. Then with respect to mobility, the other issues are convergence, right? For example, at Krakow, you have a certain response time for the network. But when you move to Warsaw, then instead of 10 milliseconds, now you have 1 second delay, then it's not going to really provide good service. So you need to make sure the network response time is good. Then when you move a VM, for example, from point A to point B, you need to ensure that the convergence, right? Because next time the packet comes to that host, shouldn't come to Krakow, then again go back to Warsaw. Rather, I would rather directly go to Warsaw. So those are the kind of things you need to ensure when you do deal with the mobility. So of course, optimizing the network and driving down the capex and opex are high on the list. So as I was talking about protection and redundancy, so there are multiple things you could do. One thing is infrastructure. How exactly you can provide physical device infrastructure, because every virtual entity needs to connect to certain physical entities. So in this case, you need to provide all active redundancy. That means hot standby in different terms. So it's not like, once something happens, you actually go to different or you activate the redundant service. Rather, if the primary goes down, automatically it switch over to the secondary. And the other part is like the redundancy locations are geographically apart. So you will have one data center in Krakow and another one in Prague, or another one in Warsaw. So you should be able to automatically switch over to different geographical location. Then the protection, right? It's not only for the physical but also the network protection, and you need to make sure you use your network resources effectively. Just because you take a redundant path, a traffic service, you want to keep it just as a hot standby, but you would rather use effectively so that you consume that network resource, so that you monetize whatever resource you have. So you make sure that the network is protected along with usage of the network resources. And you also need to provide site-to-site protection with respect to services, physical networks, and virtual networks. So if, for example, the main issue you see, right, in terms of protection and redundancy, you want to access a web page, and some disaster happened, and you cannot access that web page. So you will, as a customer, you will feel frustrated because you cannot access to that web page. It is not your fault. You still have network connectivity, but the content is not there. So that means the service is down. So you need to ensure that it's not only the network, the content also has to have protection and redundancy. So the reason why all these specifics are needed is because as a data center, as a service provider, as a content provider, you need to provide those services, and you need to meet all those requirements. So any solution you take, you need to make sure these are the requirements it has to meet. So the scalability, the fast convergence, and the looping, for example, you don't want to just go round and round. Rather, you need to avoid those loops. Security, and you should be able to enable, have multiple users at the same time. You cannot just dedicate the whole network to one customer because you want to monetize as much as possible. Then most importantly, you need to ensure the data is safe and data is secure, and it is the integrity of the data is maintained. And of course, the capex and opex has to be as minimal as possible in order to reduce the cost of operating a data center. So next, we'll talk about some of the network fabric solutions. So there are a number of solutions. I'm going to present some of these solutions, and these are not just my opinion. These are some of the data center providers who actually gave feedback based on the questionnaire I had, and I'm going to talk about some of these solutions. So the fundamental way the majority of the customers use is to interconnect two data centers using, for example, GRE tunnel model. So you take a optical pipe and you write GRE tunnels on top of that. So it is very simple. If you have small scale data centers in a few geographical locations like 2 or 3, all you need to do is establish a GRE tunnel, and you can run services on top of that. So that is backup services from data center to data center, replication services, and all that stuff. So the operationally, it is very, very simple to use. And the thing is, in order for you to, as a data center, what you need to avail is you need to avail that service, the GRE tunnel or MPLS tunnel or whatever. You need to avail that service from the service provider. So there are two entities here. One is the data center owner, and the second one is the service provider. So that means both have to work cohesively to provide the service. But the upside is intelligent. It is you don't need too much intelligence. It is very, very simple to maintain, and providing services is pretty simple. But the downside is if you have many data centers and number of hosts are too many, and if they are mobile, it is very, very difficult to provide those services on top of GRE tunnels, because the convergence time is quite high, and the maintenance cost is also too high, because there are two entities now. You do not know if something has broken. You do not know where exactly the fault is, because it could be in the service provider network. So, and also troubleshooting is really pain. So it is simple solution. Majority of the customers use, because they love the simplicity. But if you go to the virtualized model these days, it is going to be a real pain, and the capex and opex is going to be quite high as well. With respect to VPLS solution, I'm sure most of you know what VPLS solution is. It provides some multi-point to multi-point service. So you could have data centers, and you could interconnect each of those in a mesh connection model. And the primary technology used is MPLS, which is a very proven technology in service provider networks. So, and the MACs, for example, you have host devices. How to go from host A to host B on different data center. The MAC address learning is learned on a data plane, so it is not based on the control plane. So that means if there is an unknown MAC address or unknown host, you actually do the broadcast or flooding, control flooding you can call. So the main protocols used are BGP and LDP to set up LSPs and pseudowires. And the downside of that is you still need to run spanning tree protocol within the data center. So as we have talked about issues with spanning tree, they persist within the data center or within the single domain. Though the STP is present, the other thing which the other downside is there is no real native multicast. For example, I have a multicast tree on the left side, then there is no equivalent multicast tree built on the within the core. So there is no equivalent multicast tree built. So if you have a lot of multicast data, you have to deal with a lot of broadcast traffic. And troubleshooting, as you know, it is again difficult in VPLS world, because you need to troubleshoot at pseudowire level, you need to do at MPLS level, and that is in the core network. Then correlate that troubleshooting with the data center side, so which is really pain. So people are very hesitant to use VPLS, though it is popular from service provider. With respect to data center, people are hesitant to use that. So this is OTV solution, which is proprietary of a single vendor. It actually extends the layer 2 domain from one data center to the other data center. So that is, you can extend the VLAN from data center A to data center B. So what that does is, so now your layer 2 is not constrained to a single CE domain or single data center. Rather, you can extend across the core. So in order to do that, what it does is it uses IP as the mechanism within the core. So it builds the whole IP network in the core, and takes the L2 traffic, encapsulates as IP traffic, and sends it over to the other side of the data center. So the upside is that it uses IP. The downside is, as you know, in IP it is a connectionless. So you have a lot of issues in troubleshooting. You do not know how reliable the IP connections are, and the fundamental or the major issue, if you really look at OTV, is that the MAC learning is learned at the edge of the CE domain. So that so all the PEs should learn the MAC so that they could build IP tunnels or IP connections. So whole of the MAC table should be identified at PE. So that is very humongous, considering a lot of virtual devices these days each data center has. Then, of course, NVGRE and VXLAN. This is fundamentally the overlay network you build on top of the existing physical network. So the problem of interconnecting physical networks is still there, but all you're doing is you're building a virtualized network on top of the existing network. So it is not really a data center interconnect protocol, but rather a overlay protocol. And way to terminate these tunnels and all those issues still persist. And there is no clear solution because there are two competing solutions. One is based on layer 2 and another one is based on layer 3. NVGRE is layer 2, whereas VXLAN is layer 3. And one is layer 2 is more vocal proponent of layer 2 is Microsoft and other likes like Huawei. But if you talk about layer 3, Cisco and others actually push VXLAN. So this is overlay technology. Then every vendor these days is talking about how to use EVPN. So EVPN is also called as MAC VPN. So what you do is you actually build MPLS tunnels using MAC addresses. So instead of the IP addresses, you actually use, in simple terms, you use MAC addresses to build MPLS LSPs. So it is very, very technologically, it is very good, sound technology. And it uses BGP as the control plane protocol. The fundamental difference between EVPN and other technologies is the MAC addresses from data center on the left side to data center on the right side are exported over BGP. So that means control plane is actually used to do the MAC learning. So it is not learnt on the data plane. So that means the edge devices of the cloud or the core have to be aware of the MAC addresses, right? So that means the MAC learning happens on the edge, and all those MAC addresses are exported over BGP. And so what is the advantage or disadvantage? Advantage is that you have control plane to build your topology, but the downside is that it takes, if you have like thousands of devices at the startup, you have to have a lot of time to converge all of this MAC learning. So in order to do that, there are quite a bit of optimization technologies, but it's a proven technology, but not widely deployed yet. Then there is something called PBB VPN. As you all know, PBB is the IEEE technology. So they merge, it's a hybrid technology between PBB and the EVPN. So instead of exporting all the routes of customer over BGP, I would rather actually segregate the customer MACs and provider MACs, so, or the bridge MACs. So the EVPN is used, or the BGP is used to export only the provider MAC addresses, and all the CMACs are actually learned over the data plane. So the amount of MACs exported over BGP are minimal because there are not many provider devices, so the MACs are small. So that way you actually optimally could route between provider to provider, or provider domain to provider domain, and you could limit the number of MAC addresses on the network. So it actually reduces the amount of traffic. So it is very good technology, and it's not implemented yet, but it is in the works by many vendors. So this is very good technology as well. So Trill and Interconnect. So if I'm not sure how many attended Trill tutorial yesterday or Trill lecture yesterday, Trill is a very good technology catering to the data center needs. So it is fundamentally designed to, as Donald has explained yesterday, to replace the spanning tree protocol and to make use of multipath links. So it is very, very good in intra-data center. So if you actually use the Trill campuses or Trill enabled data centers, and you want to extend across multiple campuses. So there are multiple technologies you could actually use. So one is PBB EVPN. So you could actually use PBB EVPN or EVPN technology and merge with the Trill technology. So you get best of both intra-data center as inter-data center. So you're merging both the technologies and using that best of the both. And it's not only that, it's not necessary that you have to use EVPN, because EVPN or PBB EVPN, you still have service provider to manage those services. So you could actually build your own network using GRE tunnels or IPsec tunnels and run Trill on top of that. So you could extend your network fabric irrespective of within the device or across the core or across different sites. You should still be able to use Trill, and you could interconnect at different data centers. So it is very good technology which we are proposing, and I'm one of the authors on this technology. So to summarize different solutions, just to give a gist of it, each solution has pluses and minuses. So I put it into three circles, concentric circles, and as you can see, each has different advantage and disadvantage, but it boils down to mobility, scalability, and reliability. If I put all the solutions in those categories and analyze, those three actually come out on the top: EVPN, PBB EVPN, and Trill with EVPN. So this, what kind of answer it gives is that you take the existing technologies and you build on top of that, because you don't want to reinvent, or you don't want to simplify just for the sake of simplicity, because there are other issues with respect to data centers which actually cause these issues. So SDN and future. So we talked about the existing solutions or coming up solutions, but what exactly SDN, and what is the future if SDN or OpenFlow and those kind of things come into picture? What is the answer to that? So in order to do that, we need to take one step back and look at take a pragmatic view. Does one solution fits all of these requirements? Are you looking only for one solution that it solves all of your problem? As you all know, Swiss Army knife, right? It has every instrument to fix a specific thing, right? Like you want scissors, you want a screwdriver, you have everything. But is it the kind of solution are you looking for, right? So, or are you for example, in the case of data centers, right? You can ask, do I need to manage my network statically, or do I have dynamic requirements, or do I have do I need to transition from the existing legacy model to the new model, or do I want to use the existing whatever I have, the infrastructure and the technology, and build on top of that? So in order to do that, I put categorized EVPN as a base solution. So it provides all kinds of scalability. It solves scalability issues. It solves redundancy issues. It solves convergence. The operational issues also it solves. It minimizes the operational issues. And mobility is also it solves, because you could move a host from data center A to data center B, but the interconnectivity you need not really worry about the migration, so that it automatically advertises the route and you're taken care of. So is EVPN the only one solution which solves all of the issues? Are we looking at EVPN as the solution for data center interconnectivity, or SDN as the whole issue? So as if you have attended yesterday's topic, OpenFlow and SDN, is it a hype? So what SDN does is, fundamentally, it actually abstracts out the information, right, from distributed model to the centralized model, and you control based on that abstractions. You control all kinds of devices, and you can actually manage. You can efficiently provision services. You can control all your network. You can diagnose the network and all kinds of things. And actually, you can do, if you take a device-specific element manager, you can even manage ports. You can manage interfaces. And you can actually control the traffic on which interface it has to go, because you can program a flow saying that flow 1 can go into interface 1, flow 2 can go to interface 2. And similarly, you can create dynamically service. You can create a virtual interface and you can provision your network, or you can provision whole network, virtual network, and do that. So is SDN the only solution or the solution which solves all of the issues? So what we have looked at is we put both the EVPN solution and we have put the SDN solution. And we thought, you know what, it's very difficult for a customer or for a vendor, provider, or a user to pick a specific solution and say this solves all of my issues. So I would rather say that I have multiple solutions, and because these are my requirements, and I will see which one fits into my needs. So if I'm a user, if I'm a consumer of the solution, I'll go and say, okay, these are my primary requirements. These are my fundamental requirements for now, and these are my fundamental requirements 5 years from now, and I'll see which solution fits. So in order to do that, that is the traditional way of doing things. Or this is what we are trying to propose, is you bring those two solutions like EVPN as well as the SDN solution, and we also want to create a hybrid solution which actually controls the control plane. For example, you have traffic engineering tunnels, and which are built with EVPN as a solution, and you want to you could control those traffic engineering tunnels using SDN, as Ivan has explained yesterday. So you could actually control the control plane, and I would get the best out of both. So I'm not necessary that I'm subscribing to solution A or solution B, but I'm actually providing a framework within the SDN domain with the existing control plane protocols. For example, you can look at SDN controller. It can actually control the transport device. It can actually control the aggregate device, or it can even control the host. It could be, or it could even control the TOD device, and it can manage end to end, right? So you could say, if I'm going to manage with SDN controller, what is the need for EVPN? So let's take, I want to actually run EVPN solution from aggregate the edge to edge, and I could actually run SDN controller for all other entities, right, except for the edge to edge. I could still do that. So I need not necessarily that I need to pick a solution saying that I will take SDN, so I'll manage all of my network, all of the whole deal with SDN. Instead, you could actually say that I could pick EVPN for this segment, and I could pick SDN for the rest of the things. You could still do that. So that is the fundamental solution we are actually proposing. So what it does is it actually optimizes the usage of the resources, and it actually provides you the holistic view of the network, because it's not just one segment. You actually can control whole of your network, and you can see the whole of your network. And not only that, you need to manage the network. How do you manage? That means you need to have a right set of tools. So that means you need to have a management station or a management tool which you're already using. For example, you already have some core network. You're actually using that network management tool. So if you have a new solution, you don't want to bring out a new management station again for that. So rather, you want to integrate with existing management solution, and that's what we are proposing. So it integrates with existing solutions, so you need not really invest too much into the new solutions. So rather, you can actually make use of the existing devices. You can actually make use of the existing solutions, which we already have. The length and breadth of the solutions we already have. So we are trying to integrate with the existing product line, so that you need not really reinvest. If you already have these equipments, you can actually straight away use it. just with software upgrade or licensing mechanism. So the last before one slide is what are the benefits? Benefits are you could offer dynamic solutions on demand, and you're able to, if you're a service provider or if you're a data center provider, you should be able to roll out new services without any problem. Seamlessly you could roll out, that is end-to-end. And you can actually have the security built in as well. And you should be able to optimally use the existing resources rather than reinvesting for a new technology, new resources. You can actually use the existing resources because this is all built into the existing infrastructure and solution space. So in summary, the cloud services, as I started, they're not going to go away. The cloud is not going to move away. Rather, the cloud is going to be is here to stay. That means every service is pretty much provided over the internet or private network, and you have to actually use effectively the resources, and also you need to ensure that it is optimal, so that you can actually roll out new services. Because at the end of the day, from a service provider perspective, the bottom line is dollars or whatever currency it is. You need to make money, and from vendors, they need to make money. But you have to balance out both, right? You cannot just, as a vendor, I cannot just dump new devices just for the sake of solution. Rather, I would like to work with the providers and the customers to ensure that they effectively use their existing resources. And the interconnect technology, whatever we are coming up with, should cater to the needs of all the requirements which I have laid out. So, we have complete set of solutions coming up with respect to data centers, interconnect, and how to roll out new services, and how to manage the whole data center. And I think that's pretty much it, summarizes my talk. If you have any questions, I would like to take now or later.